Welcome to XFO Intelligence Podcast. Today, we're diving into something absolutely mind-blowing, a discovery that connects the dots between the most unlikely intelligent systems you can imagine. Picture this. In a lab in Japan, a single-celled organism with no brain is solving engineering problems that stump human experts. Meanwhile, students around the world are unlocking creative breakthroughs by drawing colorful branches on paper. And in Silicon Valley, artificial intelligence is generating human-like insights by predicting words. These three things seem completely unrelated, right? Wrong. They're all following the exact same fundamental patterns of intelligence. This revelation comes from an incredible article by Brendan Wong of XFO Intelligence, and I strongly encourage you to read the full piece on his blog after this episode. What Brendan has uncovered is nothing short of a universal operating system for intelligence itself. Let me start with the slime mold. Yes, you heard that right. The Physarum polycephalum is a brainless, single-celled organism that can solve complex mazes, recreate the Tokyo rail system with remarkable efficiency, and even make cost-benefit calculations about resources. How? Through three simple rules: explore randomly but follow chemical gradients, reinforce successful paths by making them thicker, and abandon unproductive routes. The beautiful thing is, this isn't random behavior. It's sophisticated computation happening at the cellular level. The slime mold demonstrates that you don't need a central control system or a sophisticated brain to solve complex problems. You just need simple rules applied consistently with good feedback mechanisms. Now, let's jump to something completely different: mind mapping. Tony Buzan's technique isn't just a pretty way to take notes. When you analyze it through first principles, you realize it's actually engineering better thinking. Traditional linear note-taking forces our brains into an unnatural, sequential format, but mind mapping embraces how our brains naturally work through radiant, associative thinking. Here's what's fascinating. Mind mapping works because it externalizes our internal thought processes. It reduces the load on our working memory, creates a visual thinking space where ideas can be manipulated, and engages multiple parts of our brain simultaneously through colors, images, and spatial arrangements. It's not decoration, it's computation. And then we have large language models like GPT-4. Despite their apparent sophistication, they operate on principles remarkably similar to our biological friends. They're essentially sophisticated pattern matchers, navigating high-dimensional spaces, learning statistical relationships between concepts, much like the slime mold learns physical relationships between food sources. The breakthrough insight is that all three systems, biological, cognitive, and artificial, share the same fundamental operating principles. First, associative navigation. They all create connections between elements. Second, emergent optimization. Intelligent solutions aren't pre-planned. They emerge through exploration and refinement. And third, the extended mind. Intelligence isn't confined to a central processor, but uses the environment as an active participant in thinking. This isn't just academic theory. It has massive practical implications. In education, we can design learning environments that work with natural cognitive processes instead of against them. In AI development, the slime mode provides blueprints for more efficient, robust systems. In organizations, we can structure companies as intelligent networks that naturally surface and reinforce good ideas. For personal productivity, you can apply these principles right now. Use mind mapping for complex planning. Structure your learning as exploratory navigation rather than linear consumption. Create external systems that serve as extended memory, and balance focused work with broad exploration. But here's the most exciting part. We're moving toward hybrid systems that combine biological, cognitive, and artificial intelligence. Imagine mind-mapping software powered by AI that suggests connections you might have missed, or learning systems that adapt in real time to your cognitive patterns. What Brendan Wong has identified is that intelligence isn't a mysterious spark confined to brains, it's an emergent property of systems that can explore, connect, and adapt. It appears wherever simple components interact to form networks that remember experiences and optimize future behavior. This is a fundamental shift in how we understand thinking itself. The spark of genius isn't just human, it's a universal property of complex systems waiting to be understood and harnessed in all its diverse forms. Again, I cannot recommend highly enough that you read Brendan Wong's full article on the XFO Intelligence blog. The depth of insight and the connections he makes are truly remarkable. This universal mind he's uncovered, expressed through slime mold tubes, mind map branches, and AI attention patterns, is telling us the same beautiful story about how intelligence navigates complexity.